All right, we're on 7.3, understanding exponents and radicals. So I think most of you know what an exponent is. We have some type of base, like 3, and then we raise it to some power, say 4. 3 is the base, 4 is the exponent. What does that mean? It means take 3 and multiply it by itself 4 times. So 3 times 3 times 3 times 3. So it's just kind of a condensed way of writing multiply 3 by itself 4 times. A radical is just this symbol, okay? Anything under here is going to, like the square root of 6. This thing here is a radical. A square root is not the only root you could take. You could take some higher root, like a fifth root. But when we're talking about a radical, we're talking about something under one of these. All right, so let's go through. We're going to talk about some rules of exponents. We're going to talk about some how to understand exponents and radicals. The first thing we're going to talk about is just writing things in expanded form. So we've already done this first example, 3 raised to the 4th power. That means 3 multiplied by itself 4 times. So x to the 5th power, that would just mean take x and multiply it by itself 5 times. So in expanded form, I would just write those all out. Condensed form would be writing it out with a single exponent. So that would just be x times x times x times x times x. On these ones, we're going to write these in expanded form, and then we're going to rewrite them using one exponent. So one exponent is going to be this form here. But before we do that, we're going to expand each one of these. So a to the 4th, that's just a multiplied by itself 4 times. Okay, and then we still have this times a to the 3rd, so basically we're just going to add on 3 more a's. So a to the 4th times a to the 3rd would just be a multiplied by itself 7 times. We count those 1, 2, 3, 4, 5, 6, 7. So to write it with a single exponent, that would just be a to the 7th power. Okay, here we have 5 to the 3rd. So if I write that in expanded form, that would be 5 multiplied by itself 3 times. And then 5 to the 4th would be 5 multiplied by itself 4 times. So if I take and multiply that by the 5 to the 3rd, I'm going to have 1, 2, 3, 4, 5, 6, 7. 7 5s. So that's going to be 5 to the 7th power written as one exponent. Now notice here the exponent 3 and 4, if I add those together, I'm going to get the 7. So I could eventually go ahead and skip this step where I write them all out and just add those two exponents together. Anytime I have the same base multiplied together, I can go ahead and add their exponents up to get to write it in the most condensed way possible. All right, so let's go ahead and try the next examples. See if we can get to the next slide here. All right, so next we're going to talk about something called the quotient property. So for the quotient property is what happens if I have the same base here. I have x on the top and x on the bottom, and I have my exponents here. What's going to happen here? What rules can we come up with that's going to help us anytime we have something like this, where something's on the top and on the bottom? So if we again write these in expanded form like we did before, we're going to kind of write them separately. X to the 5th I'm going to expand up here, x to the 3rd I'm going to expand down here. So if I have x to the 5th, I'm going to be multiplying x by itself 5 times. And whereas on the bottom I have x to the 3rd, that's multiplying x by itself 3 times. Now since everything up here is multiplied together and everything down here is multiplied together, and anything divided by itself is just 1, any matching x's, top and bottom, are just going to become a 1. So x over x is 1 for that one, x over x is a 1 for that one, and x over x is a 1 for that one. So here I don't have anything left on the bottom. So I could write a 1 on the bottom, but if I wanted to, but anytime anything's divided by 1, we don't really have to write that. And on the top here I still have 2 x's. So if I'm writing that, x times x, using a single exponent, that would just be x squared. And x squared divided by 1 is just x squared, so we'll just write that. as x squared. All right, on this one I have 7 x's on the top. Oops. 1, 2, 3, 4, 5, 6, 7. So I've got 7 on the top. On the bottom I have 4. And so I know that 4 of these x over x is going to go to a 1. That one will. That one will. That one will. So again, nothing left on the bottom, but I have 1, 2, 3 left on the top. So x to the third divided by 1 again, but I don't need to write that part. So this would just be x to the third. Now we're starting to notice here that if I take 5 and I subtract it by 3, I get 2. If I take 7 and subtract 4, I get 3. So anytime I have a quotient of exponents, with the same base, so I have a quotient of x raised to some power divided by x to some power, those will always have some that cancel. And so really, if I just take the top exponent and subtract the bottom exponent, that will give me the exponent for my new, for my simplified expression. So x to the 7th over x to the 4th becomes x to the 3rd. So here, x to the 3rd over x to the 5th. Notice that these all had a bigger number on the top. This one has a bigger number on the bottom. So again, we're going to expand this out, even though we know the rule is top exponent minus bottom exponent. We're just going to see how this works. On the top, I have 3 x's. On the bottom, I have 5. All right, so 3 of those are going to go away. That's just going to leave a 1 on the top, and here on the bottom I would have 2 x's. So that would be 1 over x squared. Okay, again, 3 minus 5 is negative 2. So notice that when my exponent is negative, that means it's going to be on the bottom of the quotient. All right, let's take a look at the next slide. So now we're going to talk about what's called the power property. So notice here that we have an exponent, and that exponent is raised to another power. So the power property is going to be what? What do we do if we have an exponent raised to another exponent? Well, if I have x to the 3rd power, I know that that means x times x times x 3 times. But then that's also raised again to the 4th power, right? So basically, I have these 3 x's multiplied by themselves 4 times. Okay, so another way to think about that. Well, let's just write those out. So I have 3 x's 1 time, and then 2 times, 3 times, and 4 times. So if I take 3 x's and multiply them by themselves 4 times, that's going to give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I wrote that as a single exponent, that's x to the 12th power. Another way I could have thought about that is I could take x to the 3rd and it's raised to the 4th power. So it's multiplying x to the 3rd times itself 4 times, and then I could have expanded out those the other way. Either way, I'm getting x to the 12th power. X squared raised to the 5th power. Remember, x squared is equal to x times x, so that's inside the parentheses. And then that's raised to the 5th power, meaning I'm going to take x times itself 5 times. So there's 1, x times x. There's 2. There's 3, 4, and 5. So that would give me 2, 4, 6, 8, 10 x's. So I could write that as a single exponent into x to the 10th. Now notice here, if I take 2 and multiply it by 5, I get 10. Notice here, if I take 3 and multiply it by 4, I get 12. So here, x to the 5th squared, I can again just multiply those 2 exponents together, and that's going to give me x to the 10th. So I don't have to write all of those on that one. But again, so that's called our power property. So anytime I have an exponent raised to another exponent, I can go ahead and I can multiply those 2 exponents together to simplify. All right. A couple more properties here. We got on our next slide here, we have the zero exponent property. So really all the zero exponent property is saying is anything raised to the 0 power is always just going to be 1. And the reason for that is, notice my first one, I have x to the first power over x. We can call that also x to the first power, right? If I don't see an exponent on something, it would be a 1. So remember from our previous thing that when I have x over x, that becomes a 1. So if I have the same power here and here, that's always just going to equal 1. And if I take 1 minus 1, right, like we did before, when we took the top exponent and subtracted the bottom exponent, that leaves me at a 0. So that's why anything raised to the 0 power equals 1, because it's really just saying it's the same number over the same number. So x to the 0 power equals 1, 23 to the 0 power equals 1. All of this whole expression, if I raise the whole thing to the 0 power, it doesn't matter what it evaluates out to in here. If I raise it to the 0 power, it's just going to equal 1. So that's kind of hard to remember sometimes, but anytime you see something raised to the 0 power, just think it's 1. It's a 1. All right, let's see. Next slide here. We got negative exponents. So if I have a negative exponent, so remember from our previous slide, we talked about taking, if I have a fraction with the same base over the same base, I do top exponent, subtract bottom exponent. And sometimes that one, if I have a smaller exponent on the bottom, on the top than I do on the bottom, I get a negative exponent. So I can rewrite this, x to the negative 7 would be the same as 1 over x to the positive 7. So anytime I see a negative exponent, basically what it means is I'm on the wrong part of the fraction. If I'm on the top, so because I could write this as x to the negative 7 over 1. If my negative exponent is on the top of a fraction, it means it belongs down at the bottom. We need to move it down and then we can make it positive. This one I could rewrite, since I have a 1 over x to the third, I could rewrite this. Another form of writing this would be x to the negative third power. And then if I have 4 to the negative 2, again, it's on the wrong part of the fraction, I'm going to move it down. It would be 1 over 4 squared. So if I have, not if I have a negative out front here, that would just make it negative. But if I have a negative in my exponent, it means I'm supposed to take that whole term that's raised to that exponent and move it to the other part of the fraction, whether that's up or down. So that's called the negative exponents, or negative exponents. It comes from the quotient property. Okay, let's see, we've got all of our rules here now summarized. So the product property, okay, remember the product property just means if I have the same base, say a to the fifth, and I multiply it by the same base, say a to the third, I'm just going to add those two exponents together. So when I have a product of two bases with exponents, I add the exponents together. That's the product property. Okay, the quotient property, it just says if I have something with the same base divided, so it's in a quotient, something. So the bases do have to be the same, but then I can just subtract the exponents. A to the fifth over a to the fourth becomes a to the 5 minus 4, which is a to the first power, which again I don't need to write an exponent if it's just a 1. So on the quotient property, we're going to subtract the exponents. And always on the quotient property, we're going to do the top exponent minus the bottom exponent. Always the top minus the bottom. The power property, again, if I have some base raised to an exponent and I raise that to another exponent, any exponent raised to another exponent, you can always just multiply those two together. So this would be a to the 3 times 5, which is a to the 15th power. The zero exponent property simply just says anything raised to the 0 power, any base raised to the 0 power is always going to equal 1. So on that one we can just write always 1. On this one we can write multiply exponents. Okay, and on a negative exponent property just says if I have some negative exponent, so if I have 1 over a to the negative 3, that's going to be a to the positive 3. Basically, we're going to flip over any fraction. If it's on the bottom, it's going to come on the top. If it's on the top, we're going to rewrite it on the bottom. We always want to have positive exponents. So if you see a negative